Hello and welcome to INE's CCI Service Provider version 5 learning path. Today in this course we will look at BGP based filtering using prefixes, basically filtering prefixes and also doing path attribute filtering. So in BGP we can basically filter in different ways. One method of filtering is filtering the prefix, irrespective of any condition. If I receive this prefix, I am going to filter this route. The second way of filtering is going to be filtering attributes in BGP. So let's say if you send me a specific BGP attribute type, I would filter the route. So let's see this. So here is an example of basically filtering a specific prefix. Here we are filtering two prefixes, which is 10.0.2.0 and 10.0.3.0. If I receive these two routes, I would accept these routes. Remaining routes I would filter. So let's in fact see this on our routers. What I would do is I will take two routers. One would be an iOS XZ router and one would be an XR1 router. Both these routers have been pre-configured for eBGP peering. So R6 is an iOS XZ and it is running BGP AS6. XR1 has been pre-configured with BGP AS19. And both these routers are establishing a BGP adjacency with each other, eBGP neighborship. So here I have these two routers. Let me show you my BGP configuration first. Show run section router BGP. So my R6 is basically advertising 3 loopbacks through BGP, which is 6.6.6.6, 16.16.16.16 and 66.66.66.66. So these three networks are being advertised to XR1. XR1 is advertising his loopback, which is 19.19.19.19, which I can see in my BGP table. Besides that, R6 is also prepending some ASs. So for example, if I look at my route map, there's a pre-configured route map on my router which is basically calling for access list 16 and access list 66. So for the network 16, I am prepending AS 20, 30 and 16. For the network 66, I am prepending 50, 70 and 66. So if I look back at XR1, and if I look at his BGP table, show BGP IPv4 unicast, I have these 4 routes coming in from R6, which is 6.6, 16, and 66. So these 3 routes are being advertised by R6 to me, which is XR1. And here is my AS path prepending, which was done, pre-configured basically on R6. Now what we will do is the first filtering that we will learn is filtering in BGP using a prefix set where I would filter 16 network and 66 network. Both these routes should basically be filtered when R6 advertises the routes. XR1 would filter those routes and not accept those routes. Remaining routes should be accepted. This can be done with a prefix set. Let's try this out. So let's first create a prefix set which basically matches these two networks that we want to filter. So prefix set, let's name this from R6. And the networks that we want to filter is going to be 16, 16, 16, 16 / 32, comma, and then 66, 66, 66, 66 / 32. So if these two networks match, let's end this set. What do we want to do? We want to drop or filter these routes. That would be done by creating a route policy. So let's create one route policy and let's name this RPL from R6. The condition is going to be if destination includes my prefix set name, which was from R6, then what do I want to do? I want to drop this traffic. So drop this traffic. Don't forget the else statement. If you remember in route maps also, there's an implicit deny. So we want the remaining traffic to be accepted. So else pass, end if and end policy. So if I look at my show run route policy, which was RPL from R6, if I look at this policy, it should show me that, in fact, I should do a commit first for me to see it. And let's see this, which says that if the prefix set from R6 matches, which contains two networks, 16.16 and 66.66. If that matches, then drop it, else accept all the other routes. Let's go back to now BGP and apply this route policy. So router BGP 19, neighbor would be 20.6.19.6, address family IPv4, unicast, and route policy would be the one that we created right here, inbound. So when I accept routes from this neighbor, check for this route policy. When I receive routes from R6, check for this route policy, and if it matches, drop those two routes. Remaining routes you can you can basically accept from R6. If I do a show BGP IPv4 unicast, you should see that I still have 6.6.6.6 in my routing table, but those two routes are basically filtered. So how did I filter this route? I just made one prefix set, which basically matches the routes. I said drop, remaining routes accept, which means pass. I called that prefix set in a route policy, and I applied the route policy to my BGP neighbor inbound, which basically drops those two routes. So this is one way of filtering a route. Now we could even filter routes by filtering based on AS number. If you remember in iOS XZ, there was something called as AS path access list, which basically uses regex to match ASs. Instead of matching prefixes, I match ASs. Similarly here, I could match traffic based on the AS. That okay, if the route originates from ASX, then filter this route. So I could do that with AS path set. Like how prefix set matches a network or a prefix, AS path set matches ASs. And you have to define the regex parameters inside that. Let's try this out on our router. So I would go back to my BGP. I'll remove that RPL that we created. And this time we would filter the AS, based on the AS in fact. So let's go back to BGP under my address family. And let me change this policy back to pass. And commit. I will remove, or I don't need to remove my RPL. I can let it be. I'm just not using it. Let's now create an AS path set that matches AS numbers. If I do a show BGP IPv4 unicast, right now I have all the three routes being learned from R6, which is 6.6. Then I have 16.16, and I have 66. All three routes are being learned at this point of time. Let's say I want to filter any routes which is basically originated from AS16. Anything that originates from AS16. So here, this is the only route which is originating from AS16. This is the only route, right? So if I had 100 routes which are originating from AS16, that should get filtered. All of those routes should get filtered. I cannot do that with prefix set. I mean, technically I could do that, but my prefix set would be really long, 100 prefixes inside that. Instead, I could just match the entire AS, and any routes which are originating from that AS gets filtered. Let's also filter any route that has AS70 as a transit path. So if you see here, I have AS70 here as a transit, right? So any routes that originates from AS16, and the second condition is any routes that transits AS70. All those routes should basically get filtered. Let's try this out. So the first thing that I would do would be to create an AS path set. Let's name this maybe my AS set. And here my condition would be iOS regex. You should give this in a single quote. So I need, the first condition was any routes that originates from AS16, right? So 16 is at the end. So for defining that, I would say underscore, which basically means space, $16, which means any AS or any AS path that ends with 16. Anything that ends with 16, and let's close this, comma. The second iOS regex would be any prefixes or any route which is learned from a transit AS70. So that's going to be underscore 70 underscore. Close this, enter. So I have these two ASs defined. Let's end this set. Let's create a new RPL, so a new route policy. Let's name this RPL AS block. And my condition would be if AS path includes this AS set, then drop, else pass. And if end policy. Let's do a commit. Let me show you my AS set. Show run AS path set. And my AS set, this is my AS set, which I have configured as of right now. That matches anything that ends with 16 and anything that has AS70 as a transit. Then I made a route policy, which was RPL AS block, which basically says that if my AS path set matches, drop it, else accept all routes from any other AS. Let's go and apply this. So router BGP 19, and let's go to neighbor 20.6.19.19 or 19.6. Address family IPv4, unicast, and route policy RPL AS block in. Let's do a commit. And let's verify our BGP table. Show BGP IPv4 unicast. As you can see, I do not have 16.16 and I do not have 66.66. Basically, what I did was I filtered the routes originating from AS16 and I filtered any routes which was basically learned which had transit AS as 70. So you see, configuring an AS set just becomes easier when you have multiple routes because I can use a regex to match ASs rather than matching prefixes. So here, you don't really need to know all the different kinds of regex parameters. Maybe caret sign means, so if you see something like this means start of line. This means end of line. So if I give something like this, caret and dollar without anything inside, it means my local AS. If I give something like caret and then maybe $25, it means neighbor AS 25. If I give without the caret just something like this, maybe just $25, this could match AS 25. This would also match AS 125 or 225 or 325 and so on. Underscore basically means space. Okay, so this was the second way of basically filtering. So configuring filtering in BGP, prefix-based filtering can be done with the prefix set, or you could do filtering using AS set. There's another way, in fact, to do filtering in BGP, which is called as attribute-based filtering. As you know that every BGP attributes, we have local preference, wait, we have MED, we have AS path, origin, communities. There's so many different types of attributes. All of these attributes basically has an attribute value. Let me in fact see if I can show you that. If I look at this document here, this basically tells you the attribute value for all of the BGP attributes. So if you look at origin is attribute number 1 for BGP, AS path is attribute number 2 as per RFC 4271. We have MED, which is 4, next hop is 3. So these are all attribute values. What I could do with BGP attribute-based filtering, if some neighbor sends me an update, if he sends me an update, and if it contains a specific attribute, I want to filter the route. Or maybe I want to remove that attribute and still process the update. So there are different options available. So one option would be that I configure it as treat as withdraw, and the second option is discard. If I let's say filter, or if my neighbor is sending me an attribute, maybe attribute number 6, which is atomic aggregate. Let's say if my neighbor was summarizing it. So when you summarize a route, which is aggregation in BGP, so when the neighbor sends you an aggregate update, if he sends you an update which is an aggregate, and I want that if he sends me an aggregate, I will discard the update, or I don't want to accept the update. I would configure a BGP attribute-based filtering with the value set as 6, which is atomic aggregate, and I would put the action as treat as withdraw. When you configure it as treat as withdraw, it basically means that if any update is received with the respective attribute, which is let's say attribute number 6, then I would not accept that update. There's another option also, which is basically discard. The difference between both of them is that treat as withdraw would not accept the update, which you can see probably here in this slide. So there are two options, treat as withdraw or discard. One thing you should know is that attribute number 1, 2, 3, 8, 14, 15, and 16, they cannot be configured for discard, or they cannot be configured for treat as withdraw, because they are well-known attributes. They're well-known, optional, and some are mandatory. You cannot configure them. You can configure local preference as treat as withdraw or even discard. You can configure atomic aggregate. So if you look at the attribute list, one was what? It was basically origin, right? You cannot say that I want to discard the update if I receive origin, because origin is well-known, mandatory, it must be present. So if it is a malformed BGP update which contains attributes which I don't need, I could filter that route. So let's see this in fact in action. What I'm going to do is, as of right now, XR1 is sending a summary prefix, which is an aggregate, to R6. Let's check R6's BGP table. So XR1 is sending us /24. Let me show you the config on XR1. Show run router BGP. So as you can see that I have done summarization on my XR1. So instead of sending the specific prefixes /32, XR1 is sending only a summary prefix. Now, what attribute value is this? Attribute value number 6. I want to filter that. So I want that if a neighbor sends me an update which contains atomic aggregate attribute, I want to filter that route. Let's try this out. All I have to do is go to R6 and say router BGP 19. or in fact it's 6. Say neighbor 20.6.19.19 path attribute. Now I have two options: treat as withdraw or discard. Treat as withdraw means what? I will not accept the update because it contains attribute number 6, which is atomic aggregate. If I keep it as discard, that attribute is discarded, but he still processes the update. Let me show you that. I will first do discard and put attribute number 6 inbound. So when I receive an update that contains atomic aggregate, then don't worry about that attribute. So remove that and still accept the route. Still process the update. So if I do a show IP BGP, I still have that network in my routing table. Okay? Now let's see the difference when I do treat as withdraw. So let me first, before I do treat as withdraw, let's do a clear first. Clear IP BGP star, a hard reset. So basically that route doesn't exist in my BGP table at all, which means I should get a new update from XR1. Can you see I still accepted the route because I had configured it as discard. The only difference is that without the discard, I'm not making any changes to the attribute. Now, the attribute number 6 was basically removed, but the update was still processed. But if I make it as treat as withdraw, the update itself will not be processed. If the route exists in the routing table, it is removed. Let's try it out. Go back to config T, router, BGP. I will remove this and I will reconfigure this as, instead of discard, I would say treat as withdraw for attribute number 6 inbound. So when I receive this update, treat it as basically remove that route. Look at the message that I got right now, that I received a malformed message from XR1, which basically contains this prefix, which has the attribute number 6 set. What do? Withdraw the routes, which means now if I look at my BGP table, I should not have 19.19.19.19 in my BGP table. So you see, I did filtering, matching not prefixes, but matching based on attributes, because you don't want malformed updates coming in from the internet or from your eBGP neighbor or from your ISP. So you basically only allow maybe well-known attributes, and like maybe you allow your AS path, which you cannot filter, or origin, or even next hop. You can do for local preference. So if somebody sends you local preference, if I choose discard, that local preference basically won't be considered. It just skips that and still accepts the update. But if I say withdraw, if he sends me a local preference, discard that route. Basically, don't use that route, remove it from your routing table. So this is another way of filtering in BGP. I hope this video was informative to you, and thank you for viewing.